Test, test. Alright. Okay. So hari ni, topik kita hari ni adalah organic compound. So kita akan continue apa yang kita dah belajar, iaitu alkane and alkene. So hari ni kita akan belajar mengenai physical properties and chemical properties. Sebelum kita dah tahu kan macam mana nak buat alkane, alkene, macam mana nak drawing. Alright. So next. Okay, yang ini adalah this one is a physical properties of alkane. Okay, so as you can see here, there is a molecular formula. I also have a melting point, relative molecular mass. We have a boiling point, okay, and then we have a physical state, also density. Alright. So as you can see, for the melting point here, so what is the physical properties of alkane for the melting point and boiling point? Okay, actually for the alkene, they exist as a low melting point and boiling point because they have a weak van der Waals forces between molecules. So we only need a small amount of energy to overcome the weak forces of attraction. But as the number of carbon increase here when down from here methane to here, when the number of carbon increase, the melting point and boiling point will increase. Melting point and boiling point. Okay. So for the ether, like for example, if we start with the methane, they have a low melting point and boiling point because again let me repeat, because they have a weak van der Waals forces which require small amount of energy to overcome the weak forces of attraction. Alright, clear? Okay, the next one. If how about the physical state? As we can see, when the number of carbon increase, the physical state also change from the gas to liquid. How about density? The density is also increase when the number of carbon is increased. Okay. So next. Okay. So here, here. So this one is what we have go through just now. Density, melting point and boiling point. And the next extra one is solubility and electrical conductivity. So let's recheck with the electrical conductivity. So the electrical conductivity, they cannot conduct electricity. Alright? Okay. So because why? Because the absence of free mobile ions makes them unable to conduct electricity. So how about the melting point and boiling point? So again, so actually they are This type is a low melting point and boiling point. So because the molecule become like this, so more energy is needed to overcome the increasing stronger intramolecular forces of attraction. So hence the number of carbon atoms per molecule increase. So as I said earlier, when the number of carbon is increased, the melting point and boiling point also increase. So you require a lot of energy to overcome um, to, to overcome the the van der Waals process of attraction. Alright. So the next one is solubility. The solubility is insoluble in water because it dissolves in organic solvent only. So they cannot dissolve in water, okay? So because they are only dissolved in organic solvent. So how about the density? So they are actually less than water. Okay, as the number of carbon atom increase, the alkane molecule will increase and also our molecular mass is increased. So hence the density of alkanes increase with increasing molecular mass. So again, so when we previous my slide is our density is increased when the number of carbon also increase. Okay, I hope you're clear about the physical state in terms of melting point, boiling point, solubility, density, and electrical conductivity. Next one. Here is now we go through about chemical properties. Okay, now we have a combustion. So for the combustion, alkane undergo complete combustion in the presence of excess air or oxygen to produce carbon dioxide and water. Okay, if we have they undergo the complete combustion, they will produce carbon dioxide and water. Okay, for example, let's we try one or two example of organic compound that we have learned. So for example, I take a methane CH4. This is a CH4, okay? Okay, CH4 when you burn, you are produced. Okay, let me again see. Okay. Right, so I have CH4 when I react with oxygen. So we know that this is the O2, okay, and we know that we can form the CO2 and also with water. Okay, this is a 2. So don't forget to balance. Every time you do the chemical equation, you need to balance. Okay, are they balanced or not? So they are not balanced, okay, because our reactant have a hydrogen 4, but our product we only have a 2. So we put 2 here, 2 times 2, 4 for hydrogen, and I also have 2 oxygen here, and also have 2 oxygen here. So 2 plus 2, you can get 4. So my reactant, I have to put 2 because when 2 times 2, that's 4. Okay. Alright. So next, how about we try another one? So let's try. Okay, let's say I ethane. So C2H6 react with oxygen. When we complete conversion, and then again we can form CO2 and H2O. This is a plus, okay? So they are balanced or not? So because your hydrogen in reaction you have a 6, but in product you only have 2. So then you have to put 3. So let's check here. Oh, first one you have to balance your carbon. So then I will put 2 carbon, and then my carbon is 2. 2 for the 2 times 2 here. 4. It suddenly disappear. Alright, that's okay. Okay, let me get back. Alright, so here, so C2H6 plus with O2, and then I can produce CO2 plus with H2O, and then I have to balance 7. I will put 7 and 4, and also with 6. So the next one, the combustion of alkane is highly exothermic, produce a lot of heat. So if your alkane is incomplete combustion, we will produce carbon monoxide. Okay, we cannot produce CO2, which is carbon dioxide. And incomplete combustion, we will produce carbon monoxide and water. Alright. So next one. So in this chemical properties of alkene, you have we have what? So we have a combustion, and we also have substitution reaction. So in a substitution reaction, the hydrogen atoms in alkene are replaced gradually by chlorine atom. Okay, for example, okay, so for example, I give a say CH4, okay, will react like chlorine. Okay, so automatically we can form. So this is our hydrogen, right? If I draw here, and I have a chlorine here. So this chlorine will substitute, and the hydrogen will substitute with Cl. So I can create CH3. This is 3, and then CCl. That is HCl. Alright. So this is substitution. So you can continue from here. CH3, Cl, and then you react with chlorine again. Then we can form CH2, Cl2. Okay. For example here. Alright. Okay. Here, this is okay. I just okay. So for example, like again, I continue with okay, I can use my just give me there's not on my phone. Oh, let me. All right. So here, next we continue for substitution. So this one we can. Okay, for this one, let's say I have CH4. CH4. Just now I create with Cl2 and then we can form CH3 and together with Cl react with hydrochloric acid. Now we start from here. So my CH3 Cl react with another chlorine Cl2. So what we produce? So we can produce what? So okay, let me draw our. Here we already have a chlorine. This is a H, the chlorine, and this is our H here. And then there's a H, and then I have a chlorine. So again, this chlorine we substitute with this type here, and this hydrogen together with Cl. So I can form so CH2 Cl2 react with, and then hydrochloric acid, HCl. So this substitution will you can form okay, until the name is tetrachloromethane. This one the name is dichloromethane because we have a two di. Here is chloromethane. Oh, okay. Chloromethane. And here is dichloromethane. And then you can form trichloromethane and then until so on. Tetrachloromethane. Next. Okay, here I have exercise for you. You can try a few more questions. So name and give the molecular formula of, of an alkane with 3 carbon atoms. This is what 3 carbon atoms. Can you recall that? Okay, this is 3 carbon atom is propane. So the answer is propane. So propane is we have a 3 carbon, so C3H8. And also you can using the formula. So CnH2 and plus with 2. So when you put 3, C3H6 plus with 2, and then we can get so C3H8. Alright. So you can also use the general formula of alkene. How about the 5 carbon atom? So what is the 5 carbon atom? The name is pentane. Pentane. Okay. And the general formula is pentane is 5, so C5, 5 times 2 times plus 2, and then we can get H12. Okay, how about 6 carbon atom? Hexanes, okay? And so on. So this is what we have learned during our first class. Okay. How about we try here? Petrol used in car consists of mainly of octane. Alright. So give the molecular formula of octane. What is the molecular of octane? So just substitute, you can use CnH2n plus 2. And then, so the octane is C8, C8 and also with H 18. Okay, right? An equation for the complete combustion of octane. Now you want do the chemical equation. So we know that the octane is C8H18. So here C8H18. Alright. And then we react with oxygen, and then we can form so CO2 plus with H2O. Alright. So this one we have to balance. So can you balance? Can you try to balance? So we have a C8. Then I have to put my carbon here. I have 8. Then I can put here 18. 8 also. And then my hydrogen is 18. So what is the number here? I should write. So 8 because here is 18, correct? How much? Because we want to have hydrogen is 18. So for hydrogen, so this one is right here. Carbon is 8. Hydrogen is 18. Oxygen is 2. Now I have carbon is 8. So oxygen is 16. So this is 2. Okay. Hydrogen here I have 2. Oxygen I have 1. So my carbon is already balanced. So if you want to balance, the last one is must be oxygen. So we need to balance for the hydrogen. So we have 18 here. Hydrogen is 18. And then we also have to put, because if like 6 times 2, 12. Let me try to put 9 here. Oh yeah, 9 times 2 can get 18. So here it's already 18. Okay, this is 18. And my oxygen is here is 9. 9. Alright. So carbon is already balanced, hydrogen already balanced. The total for oxygen is 16 plus with 9. We can have this side and this side. So 16 plus with 9, we can have 25. But in our reaction, we only have 2. So what we should do, I will put 25 here. 25 over 2. So just make it like 25 over 2 times with 2. So we will cross the 2 and then we left 25. So you can give this kind of chemical equation. Don't be afraid with the fraction. So you can write 25 over 2 also can. If you don't like to hear this kind of fraction, so it's okay. So we can try to make it there is no 2 on the fraction. Okay, let me use this one. Okay. So I will bring 2 here. I will take this 2 and then I will multiply with all the organic compounds. So I can put 2 here. So this one is already disappear. And then 8 times 2 can get 16. So this one becomes 16. And then 9 times 2, this one becomes 18. Okay, the final answer is, you can write, so 2C8H18 plus with 25O2, and then you can form so 16 CO2 plus with 18 H2O plus with H2O. H2O here. Alright. Or you can give like the blue color here also can, or the green color also can. So I hope we can try number one and two then. So next, number three. Here, ethane. Ethane react with chlorine under certain condition to form chloroethane. Take the condition for reaction to take place. So ethane, we have this is a alkane when you react with chlorine under certain condition, and then we can form the chloroethane. So the next day, the condition for reaction to take place is must have the presence of ultraviolet light or sunlight. Then the reaction takes place substitution reaction. Okay, from when alkane react with the, for example, like chlorine. So because they are substitute, right? So the name is the reaction is substitution. So this one is substitution. And then write an equation. So I have equation so C2H6, and then I react with chlorine, react with Cl2, and then we can form here. So C2H5, Cl, and also with HCl. I hope you know how we can get the C2H5Cl here. So let me recall back. So you have a two hydrogen, two carbon, and the rest you fill up with the hydrogen. After that, you react with chlorine. So again, this chlorine will substitute. You will substitute with the hydrogen phase, and this hydrogen will substitute. So that's why we can get the C2H5Cl. Okay. So here, so just put the rest is hydrogen. And don't forget here, you have to put chlorine. And also with HCl. Okay, the last one for number 4. So a saturated hydrocarbon X has a relative molecular mass of 58. So identify what is X. Okay. So we know that saturated, this is the clue. Okay, clue. Unsaturated, no, mostly it's double bond, triple bond. So the saturated is alkane. So we do not know what kind of organic compound for the alkane. So we need to identify. So we can use the formula. So CnH2n plus with 2 equals to 58. Okay, how the carbon is, we just try to calculate using the how we want to calculate the molar mass. So carbon is 12, 12 times together with n plus with hydrogen is what? Hydrogen is 1. So 1 times 2, 2, and then 2n plus with 2 equals to 58. So 12n plus with 2n, we can have 48n. 58 minus with 2, we have 56. And n is, so 56 divided by 14, we can have 4. Therefore, we know that this is a, so C4 is 4 times 2, 8 plus with 2, and then we can have 10. So this is a butane. Name is butane. Okay. So I hope you clear how to solve this kind of question. Okay, let's we move on for the alkene. Okay, here is the physical um, properties of alkene. Okay. So we can see the melting point and boiling point here. The melting point, the melting point, boiling point. The relative molecular mass also increased. The physical state also change, and the density also. Actually, this one is for alkene. Okay. Uh, they make let me cut here alkene. Because here we have a ketene, propene, butene, pentene, hexene, heptene, octane, nonene, and ketene. So what we can conclude from these physical properties of alkene. So what is the okay? So the melting point and boiling point is due to weak. They have a weak van der Waals forces between molecules. If the number of carbon is increased, the melting point and boiling point also increase. The physical state is from the gas to the liquid. The density increase also. Okay, let's move to the next slide. Here is a physical properties of alkene. They are actually same with the alkene. So electrical conductivity also you cannot conduct electricity because the absence of free mobile ions, thus they are unable to conduct electricity. And the melting point and boiling point, they have a low melting point. As we know, when the number of carbon per molecule increase, the size of molecule become bigger, so the internuclear force grows stronger. So more energy needed to overcome the stronger forces of attraction. So we can say hence the melting point and boiling point increase with the increasing number of carbon atoms per molecule. Just easy, we can just I already show you the table the table. So it's due to itself they have low melting point. When the number of carbon increase, so your melting point and boiling point also can be increased. Right? So how about the solubility? So they are insoluble in water because it dissolves in organic solvent only. And then density, yeah, less than water. So same as with the physical characteristics of the alkene. As the number of carbon atom increase, the alkene molecule increase, and our molecular mass also increase. So the density of alkene also increase. Okay, next one. Let's move on here. So for the chemical properties of alkene. Okay, so let me right. So this is alkene. I put opposite. Okay, there is a combustion of alkene. So when alkene undergo complete combustion, so we can produce same with the alkene, which is carbon dioxide and water. Alright, so the combustion of alkene is more smoother than alkene with the same number of carbon atoms. So this is because the percentage by mass of carbon in alkene higher than the alkene. So we will prove this one. And then we will do this one. Before that, I will give a for example. Let's say I took ethene. So C2H4, when you react with the oxygen, then which is undergo combustion, we know that we need to form CO2 plus with H2O. So we just have to balance. So this one we have two here, so I will put two here. my hydrogen, I have hydrogen for the reaction, I have 4, then I will put 2 here. 2 times 2, we got a 4, right? And then what else? How about our oxygen? So here, the last one, so because oxygen is here is 4, and oxygen here is 2. 4 plus 2, 6. Then I will put 3. Okay. So now, let's we go through this one. Let's Okay, we want to prove is it true the combustion of alkene is more nuclear than alkane. But the reason say the percentage by mass of carbon in alkene is higher than of alkene. So let's we check. So let's say we take hexane and hexene. So I have hexane and I have also hexene. So for hexene first. So we know that this is C6H14. The molar mass is 86. For the hexane is C6H12. Hexene. Yeah. So for the hexane C6H12, the 84. Okay, for the hexane, okay, so for the hexane is 86. Right. So after that, now we want to calculate the percentage by mass of carbon. So you focus on carbon only. So for the hexane, so I have a 6 here. So 6 times 12. And then don't forget over with 86 times with 100%. For the hexane, I can get 83.7 percent. 83.7%. How about hexene? Can you try? Same. I have 6 here times with 12 and together with 4 times with 100. This is times, okay? Times, times 100, 85.7%. So from here, we know that the percentage by mass of carbon in alkene higher than of alkene. So here is the proof. So we have hexane and also with hexane. So next one. Here is the chemical properties of alkene. The first one is combustion, and the second one is addition. So inside the addition, so we have a lot, which is hydrogenation, halogen, hydration, acidified potassium manganate, hydrogen halide, and also with the polymerization. So we try to go through one by one. For the hydrogen, so under the addition process for the hydrogenation. Okay, let's say I give you propene, so C3H6, okay, and then you react with hydrogen. And then you must have a catalyst, which is a nickel together with or platinum, okay. what we can form. So this one, the process is the hydrogen or hydrogenation. The alkene is converted into alkene. Maybe you can take note here. So alkene is converted alkene. Okay, from alkene you want to become alkene, the process is hydrogenation. So sometimes this one we want hydrogenation is used to make margarine. Okay, from vegetable oil is in a liquid form. Okay, try. What is our product? Okay, C3H6 here. So I have a C3. It is this one. Okay, so I have C3, and then okay, double bond. H 1, 2, 3, 4, 5, and 6. Okay. Here we cannot put the hydrogen here because they already fully carbon with only with the 4 carbon. Because we have 1, 2, and then we have 3 here, and then we have here 4. The maximum carbon can substitute is only 4 carbon. So now you have a hydrogen. So this hydrogen, we break the bond of double bond. So here, we will break. And then so this hydrogen we substitute into inside here. Okay, that's mean this is your final one. So let me, we have 3 carbon. The rest we just fill up with the hydrogen first. As you can see here, because this hydrogen we substitute, they will break bond, and then you put hydrogen here. Right, that's why they from the alkene you want to convert into alkene. Now we have C3. So from propene, this is a propene. From propene to propene. Alright, I hope you know how we want to get the hydrogenation. So now next now is halogenation. So for the halogenation, so halogen is basically for the group 17, bromine, chlorine. Okay, so let's say you have an ethene, you react with a bromine, and then what we can form. So here let's say I give you C2H4, and then you react with the bromine. So what is the name here? Is a ethene. Okay? Ethene. So basically, for the if you put the bromine, we want to test if either we can distinguish between alkanes or alkenes. Okay, let's say the teacher asks you, can you choose? Can you take the alkene? So now, when you see on the table, they are colorless. So how do you want to differentiate between the alkene and alkene? So you can put bromine, or you can put actually you can put also potassium manganate seven solution. So here from here when you see 2H4, can you try here? What is the result? Okay, so let me write here. This is a chemical test to distinguish alkenes from alkene. So if you test for both of solutions, you can see an alkene, they will decolorize the brown color of liquid. So if for the alkene, alkene do not decolorize. If you take note this one, if you have alkene, so the alkene they will decolorize. Okay, okay. Okay, for the if you have alkene, do not decolorize. Okay. So this is we can chemical test to distinguish between alkene and alkene. So remember for the alkene, they will decolorize the brown color. For the alkene, do not decolorize. Okay, for the C2H4, okay, we write this. We draw the here. So we have carbon 2. Don't forget double bond. So you can put here hydrogen. The rest is hydrogen. And then here hydrogen. There's the bond here. And then you react with a bromine. So this one, the bromine will break the bond. Okay. Okay. And then we can form here. So let me write using the hand 1, 2. And then we have a bromine. Okay. Here we know the name is here is ethene. So this is a ethene. So your final answer should be you can write here C2H4 Br2. So should be no problem. So what is the name for this one? Okay. If you want naming for this kind of compound. Here. So I have we have let me put number 1 here and then it's number 2. So they have a 2. So if you want to try to name it, so we have to write 1, 2, and because they have 2, we need to put di. Anything like because they have a di. So di, bromo, because the bromine is bromo. If chlorine is chloro, if chlorine is chloro, okay, di, bromo, ethane, right? Right. So what we have learned is only for the alkene hydrogenation, which is we know that the hydrogenation is from al alkene we want to form to alkane, which is under we can use to make margarine. And then don't forget to put the presence of nickel or platinum as a catalyst. Now for the halogenation, we can do a chemical test to distinguish between alkene and also with alkene. So alkene, they will decolorize the brown color. Alkene, they will do not decolorize color. Alright, so here is example when you have ethene, you will use bromine. So and then we can form 1,2-dibromo ethane. So it's better for you to draw. I encourage my students to draw first so that you know how to name the compound. Okay. So maybe inshallah. So we will continue again this topic because we still not finished for the chemical properties of alkene. Right. So we will stop here, and then we can do some of exercise later in the next class, inshallah. So I hope you can get what you have learned today, and you now you are much more better to understand about the organic compound. All right, okay, so we will stop here and see you next time, inshallah. All right, bye.